So imagine you're in economics class and you're looking at a classic labor supply and demand curve. The labor market or employment is as the independent variable, and you're in math class, so you're used to using the independent variable to find the dependent variable. In this case, the minimum wage would be the y, and you're kind of realizing how this doesn't make sense because you're usually not in situations where the employment is drastically changing before the minimum wage. So you rewrite this in a way that makes sense. You put the minimum wage on the x-axis because it's the most independent variable, and you figure that employment is going to most depend on the minimum wage, right? And so you graph it, and as the minimum wage goes up, right, people are going to want to work more. And you kind of figure that it's kind of the opposite relationship for the demand. And then you have this perfect equilibrium, right? This equilibrium is right when the supply-demand curve cross, right? It's this place with low unemployment. It has unchanging minimum wage. And it's usually the reason people say, if you raise the minimum wage, you're going to have dead loss because it's this perfect equilibrium. But that doesn't really make sense because you're remembering how your brother lived in Seattle in 2016 and they actually raised the minimum wage from $12 to $15 in Seattle. And the labor market grew, which isn't dead weight loss, it's actually gain. And in order for that to be possible, there has to be at least two market equilibriums. Or we can also look at 1967, where the minimum wage was at an all-time high adjusted for inflation. And the unemployment was at an all-time low. And that doesn't really make sense if we look at our graph. That's not how it should be. So let's make our graph again. Let's make it more mathematically correct with multiple intersections. So you make a graph, you put employment and minimum wage on the x-axis, of course, and you kind of graph your supply, and the supply shouldn't change that much because, people are going to be paid and then they're going to want to work. Pretty simple. But you're trying to graph the demand, and there's so many different factors. Like, what if people want to spend the more money they're making into the local businesses? Then there could be two different intersections, right? So you kind of figure maybe it's a parabola. So you kind of label where it might be, or in Seattle in 2016, where it was $12, and you label where it was $15, right? We can make this work. So you label it and you draw a parabola. Well, that seems like a good thing. Maybe that's what Seattle's demand curve. But you figure, what if there are infinite different equilibriums, right? And so you draw a cosine sine graph, right? That's roughly what it looks like. And you kind of draw, it goes up and down and up and down and up and down. Now you have all these different equilibriums. So and you can also draw it so that the demand curve is actually a circle, which is not a function, so you can't graph it. And does that mean that not in all situations you can graph human behavior? Wow, what a realization. So this is how we're teaching it. We're saying that you can't change minimum wage when you can. It's been historically proven, and that's because this model is based off of selfishness. We should stop teaching that. Teach kids to change the minimum wage because a higher minimum wage is good. Thank you.